friends, in this video we are going to study the various factors which will influence the selection of the transducers. So let's start with our topic. In a measurement system, the transducer, its main function is to convert the non-electrical quantity into an electrical quantity, so that various electrical methods can be applied over that electrical quantity. Now, it may be possible that in that measurement system where we are using the transducer, there may be two or more physical quantities or non-electrical quantities which are influencing the transducers. So the output of the transducer, it may be influenced by the various physical quantities which are present in its input, and its output may be affected. So a transducer, it should be capable of giving its response only for that physical quantity for which it is being used. Like suppose that in a measurement system we are using a transducer which is used for the conversion of a displacement into a voltage. Okay. Now there are also other factors like pressure is also present there, and temperature is also present, and due to that also these factors are also influencing the measurement of the transducer. So transducer is giving its response related to the displacement also, related to temperature also, and related to pressure also. So the output quantity, that is the voltage, it will be affected. So it is expected that the transducer which we are using in a measurement system, it should be influenced by the physical quantity for which it is used. Okay, it must be sensitive to that physical parameter only. Okay, so here we are going to study some of the factors which will influence the choice of transducer for a measurement system, or we can say the selection criteria of the transducer, that on what factors the transducer is selected for a particular application. In this, we are having the first factor as the operating principle. When we are using a transducer for a particular application, we should be aware of that for what purpose we are using that transducer. Okay, so what is the principle of operation of that transducer, how that transducer works, and is that transducer be useful for our application. Okay, so first we should know the operating principle of the transducer. Now the transducer, they can use various types of principle of operation, like they may be resistive, they may be inductive, capacitive, piezoelectric, magnetostrictive, optical transducers can be there. So depending upon our applications, the transducer will be selected depending upon their principle of operation. So principle of operation, it can be resistive, so the transducers, the first selection criteria or the first factor which is influencing the choice of transducer is their operating principle, that on which principle they are working. When we are using a transducer in a particular application, we want that transducer should be sensitive to the input. Means when we are having any changes in the input, of a very small input is being applied to the system, the transducer, it should be so sensitive that it can detect that small input and give us a detectable output. Next is the operating range. Now the operating range is the range over the maximum and the minimum values over which the transducer is working. Now over this complete operating range, the transducer, it should be capable of giving us a good output and a good resolution. Okay, so operating range. So it is expected that transducer should maintain the range requirements and it should also give a good resolution over its entire range. Now the rating of the transducer. Rating means that on a transducer, when it is manufactured by the companies, then over that various specifications are written that on what voltage and current levels it can operate. So these are called the ratings of the transducer. So the ratings of the transducer, they should be sufficient that when the transducer is working in a specified range, the transducer should not break down. Okay, means that if we are given that it is this transducer, it should work in this voltage range and this current range only. So when we are using that transducer in that specified range only, it should not be there that transducer would break down or get damaged in that range. So the transducer, it should maintain the range requirements which are given on it, the ratings which are given on it, and it should have a good resolution over its entire range, means over the entire maximum and the minimum values or the entire range, it is going to give the accurate and the consistent performance over all the values. Next is accuracy. So a transducer, it should be accurate enough, means the output value which is given by the transducer, it should be very close to its input value. Okay, there should be no difference, no error will be produced by the transducer. So for the accuracy, high degree of accuracy is required. Now, for a good accuracy, it is required that the transducer, it should not be frequently calibrated. Calibration is done only when we want that the transducer, it should give us a perfect value. So we are going to calibrate it with a standard quantity. And now if an instrument, it is requiring very frequent calibration, it means that transducer is not an accurate transducer. So high degree of accuracy will be in the case when the transducer is not requiring frequent calibration, and also it is having very small value of the repeatability. Repeatability means that when we are doing same measurements are being done again and again, same input quantity is being measured by the transducer, and all the output values or all the measured values, they are very close to each other. It means that the transducer, it is having a very good repeatability, having a better repeatability, that all the values are repeating itself. So in that case also, it is said that the transducer is an accurate instrument. Okay, so accuracy will be in the case when the instrument is not requiring frequent calibration, and also it is having a very small value of repeatability. Next requirement is the cross sensitivity. Now this cross sensitivity is to be taken into account when the transducer they are measuring the mechanical quantities. So when we are measuring the mechanical quantities, there are some situations when the actual quantity which we are measuring, it is in one plane and the transducer, it is in another plane. So the transducer, it is giving us the measurement values due to the uh, variations in the other plane which is perpendicular to the required plane. So in that case, it is called the cross sensitivity, because variations is in one plane and the actual output which we are getting, it is in another plane which is perpendicular to that required plane. So here it is called the cross sensitivity. So the transducer, it should have a very good cross sensitivity. It can measure the variations in the all the planes in which we are measuring the mechanical quantities whenever we are doing the mechanical measurements. Next is errors. It should be expected that the transducer, it should produce very minimum errors. It should have very good input output relationships, and minimum errors will be produced should be produced by the transducers. Next factor which influence the selection of transducer is the loading effects. Loading effect occurs in the cases when we are having various stages in an instrumentation system, and these stages they are going to load, means one stage is going to load the other stage, the second stage is going to load the third stage. So in this way the loading effect is introduced. Now to reduce the loading effect, it is expected that the instrument, it should have a high input impedance and low output impedance. So the same is expected from a transducer, because when a transducer is used in an instrumentation and measurement system, in that system also we are having many number of components. So when the transducer is introduced, it can have loading effects also. It can load the system. So minimum loading effects should be introduced by the transducer, and for that transducer should have high input impedance and low output impedance. Next is transient and frequency response. If we talk about the transient and the frequency response, in these two responses, the instrument, it should have some specifications, like transient specifications are there and frequency response specifications are also there. So it is expected that the transducer, it should meet these specifications like peak overshoot, rise time, fall time, delay time and settling time. So whatever values it is having over the, or whatever specifications are specified on the transducer, it should meet those specifications. Okay. And also like it is having the dynamic error, so the transducer it should have a small dynamic error. And if we talk about the frequency response curve, its frequency response curve should also be idle. Okay, it should have a idle flat frequency curve. So if we talk about transient and frequency response, a transducer should meet its transient specifications and its frequency response should be ideally flat. Next factor is, it means that when the transducer is used in an application, if some environmental factors are influencing it, like the temperature, pressure, humidity, acceleration, shock, vibrations, corrosion, all these are the environmental factors which can influence the transducer. So the transducer it should be capable enough to overcome these environmental conditions and it should not break down during its operation. Okay, so like that under these environmental conditions the transducer it should maintain its input output relationships also, and it should not break down or it should not be damaged by these environmental factors. So what are the factors which can influence it? The transducer it should be able, it should be able to withstand the pressure variations. So under all type of environmental condition, the transducer should be able to withstand all these variations like pressure variations, shock, vibrations. If there is any corrosive environment, it should be able to work in that also. And the temperature and pressure variations and acceleration, humidity, all these factors cannot influence the working of the transducer. Next is insensitivity to the unwanted signals. The unwanted signals are called the noise. So the transducer it should be less sensitive to the unwanted and undesirable signals. Like when the input signal is given to the transducer, that input signal it may have unwanted and undesirable signals also present across it. So the transducer it should be sensitive to the particular input signal only and less sensitive to the other signals surrounding the input signal. Okay, so the transducer it should be minimally sensitive to the unwanted signals. So the transducer it should be sensitive to the desirable signals only. It is going to detect the desirable signals and it is not going to detect the unwanted signals, less sensitive towards them. Next is usage and when we are selecting a transducer for a particular application, then its versatility, that for how many period it can be used or how long it can be used, and continuously for how much hours it can be used, its size, its portability, and its weight, all should be considered when it is selected for a particular application. Next factor influencing the choice of transducer is its electrical aspects. Now, the electrical aspects that need to be considered while selecting our transducers are the length and the type of cable needed, like when we are using the transducer in the laboratories or in the instrumentation system. So, what is the length and what is the type of cable which is to be used so that it can be connected, connections of the transducers, what type of cable we are using. Okay, because sometimes these transducer they are used in conjunction with the other devices also. So here it is necessary that what are its electrical aspects, that how much voltage, how much current, what is the length, what is the type of cable, what is the specifications of its output, and what are the specifications of the input of the transducer, all should be considered when a transducer is used for a particular application. So all these electrical aspects should also be considered while selecting the transducers. Next is stability and reliability. A transducer should be very much stable during its whole operating life. Like when suppose that we are using the transducer after 1 year, so same performance and same output should be given by the transducer. Its performance should not degrade with its operating life. Okay, so it should be stable and it should it should be reliable, means it is going to give us the accurate results. So both the stability and reliability of a transducer should be assured for its application in the instrumentation system. Stable means it is going to give us an accurate results over its complete operation and the storage life. Next is static characteristics. Now, under this static characteristics, there are various characteristics which come like accuracy, precision, reliability, dead zone, and resolution, hysteresis. So, all these static characteristics, along with the static error, it should be good for the transducer. So transducer, it should have low non-linearity, low hysteresis, high resolution, and a high degree of repeatability. All these are static characteristics of a transducer. So the transducer, it should meet its static characteristics along with having a low static error. Okay. Now also the transducer, it should be free from the overload. Like when overload conditions occur, then transducer is used in that condition. It should not affect the performance of the transducer. It should be able to work in all type of operating conditions. So these are all the factors which are taken care when we are selecting a transducer for a particular applications. So we can say that it is the selection criteria of the transducers or the factors affecting the choice of a transducer. So here we have studied these factors in details, and I hope that this topic is now clear to you. Thank you.